So this will be a bit of a review from the last lecture, the first lecture in chapter 10, but it's important, so I want to make sure that you understand. So if we wanted to calculate a marginal mean, that's defined as the mean for all the scores within a level of a factor. So you're looking at one factor at a time, one independent variable at a time, and you're calculating the mean for all the scores in that level. So let's start with hemispheric dominance. We need to find the mean of all the scores of the left level, okay? Because left hemispheric dominance was one level. So here, left is represented by a column. So these are creativity scores, and all we're going to do is we're going to add them up and divide by however many we have. And that is going to give you this marginal mean, the marginal mean for the left group. Once we have that, then we move over to the right group. And again, it's the mean of all these scores in the column because right is represented by a column. So you're going to ignore anything to do with marijuana. It's like it doesn't exist. So you're going to just take the mean of all these scores and get this marginal mean. All right, the marginal mean for right. So when we did this for the left, we were ignoring, again, marijuana. You have to ignore the other factor. You're only looking at one factor at a time when you're calculating marginal means. Okay, so these would, again, be the marginal means for the left group and for the right group. What about the marginal means for marijuana? Well, now marijuana is represented by rows. So we're going to focus on row 1. And to do this, we have to ignore completely the other factors. So we're going to ignore hemispheric dominance. And we're just going to calculate the mean of all of the scores in row 1. And that will give us the marginal mean for none. Then we're going to do the same thing, but this time for the one joint group. We're going to look at all these scores in this row. All right, so it's all of these scores and these scores. We're going to calculate the mean of all of them. And this is going to be the mean, the marginal mean for the one joint group. And then again, we do this for the two joint group. So again, we're looking across the row. We calculate the mean of all these scores, and that gives us the marginal mean for the two joint group. What about cell means? Well, remember that a cell represents a treatment combination. Left and none would be here. Right and 1 would be here. Left and 2 would be down here. All right, so each cell represents a different treatment combination. So when you're looking at a cell mean, you only look at the scores within that cell. So this mean here would be the mean of these 5 scores. All right, this cell mean would be the mean of these 5 scores. So we could say that the cell mean, 81.4, is the mean for the combined effect of left and one joint. Over here, this cell mean, 47.0, would be the mean for the treatment combination, the cell mean treatment combination of right and two joints. All right. How many cells would the most basic two-way ANOVA have? Well, you should have read about that in your book already. But to have a basic two-way ANOVA, the most simple two-way ANOVA possible would be a 2x2. 2x2 means, first of all, you have two factors, okay, because you have two numbers, a 2 times a 2. So you have two positions. So that means you have two factors. And each factor, in order to be tested, has to have at least 2 levels, right? So if we're going to test the effect of hemispheric dominance, we can't just say we're testing left. Because how can we see if hemispheric dominance has any effect if you only test left? You have to have a comparison group. So in the very least, hemispheric dominance would have to have 2 levels. The same thing for marijuana. We could simplify this, get rid of the 2-joint group. That would put everybody over the edge, right? So maybe we shouldn't have it. Of course, some would argue we should. I'm not going there. All right, so in the very least, you'd have to have at least 2 levels of marijuana to make a comparison, right? To see if marijuana is having an effect. So if we have a 2 by 2, that would give us 1, 2, 3, 4 cells. Okay, so remember this drops out if we have a 2 by 2. So even the simplest 2A ANOVA is going to have 4 cells. It's going to have 2 levels of the first factor and 2 levels of the second factor.